I'm CK. Tonight we're going to continue doing some GickFun projects. I've been having some success with their beginner and learning soldering kits, so I got a couple more from Amazon and we'll see what they're like. This one tonight, I'm not quite sure what it is. It's electronic colorful 10 ... electronic. So we'll see what it is. Hope you enjoy the video. Let's see what we have. As you can see, this is from the Ding Dong store, whose motto is "Make electronics, do it now." Okay, I will. Someday the hardest thing about a project will not be me getting it out of the bag. Battery box. Let's look at that little piece of paper. Okay. Oh, this is nice. Ding Dong Store, soldering practice kits, provider for electronic beginners. Jumpstart your journey of electronics. There, I'll leave that there just for a second. Let me zoom it in a little bit if you want to read it. I don't want to read it out loud, even though I'm wasting enough time, so I could probably read it out loud. But here's the instructions, or maybe the instructions, I'm assuming that. You never know. One sheet of paper, colorful LED lights, couple of batteries. Through soldering the kit, you can learn to master the relevant soldering points and independently complete the soldering practice. Yep. Oh, I get it. This appears to be a voice-controlled lamp. Nice schematic. It's obviously not very complicated. And this is a CD4017 chip. So, simple circuit, the microphone converts sound signal into electrical, coupled to Q1 for amplification by C2. And then it tells you how it works, which is really nice. This little paragraph here is a very good, simplified, straightforward description of what the product does. So that's really good. I like this already. And again, that's not just GickFun. This sheet was created by the Ding Dong store itself. So they've added value besides just reselling it, which is pretty cool. Oh gosh, this is going to take about 10 minutes to do. Here's the circuit board. Whole bunch of LEDs. A couple of resistors, another diode, the microphone, I believe, resistors. Now, there are no values here, so I don't know where we're going to get the values from. And there's the chip. Backside is unmarked, so I'm not sure if this is actually from GickFun. The circuit board does not look like their style of circuit board, so I could very well be wrong. Ooh, jumper, jumper, jumper. So they didn't really have, they didn't put their most advanced circuit board designer on this kit to have 3 jumpers on the board. That's so simple. Probably a beginning designer. There's a couple of resistors, LEDs. There's the microphone with the pins bent way out. Some electrolytic caps. Junction for power. Transistors. And the CD4017. Now, I don't know who this is manufactured by. It's got something that's reminiscent of a TI logo, but it is not a TI logo. So they're not trying to cheat too badly. But let's see what we've got here. Okay, so the schematic does have values so we can figure out where the resistors and capacitors go based on tracing the schematic. So first thing, one thing I'm going to do right now, where did I put my solder block? Okay, a little break in the action while I figure out where my solder block is. Oh, I couldn't find it, which is really weird, because a lavender block of silicon rubber is hard to lose, but I guess I did. But I have a spare. Always have a spare. So what I'm going to do, I'm going to test a couple of these LEDs and show you, if you hadn't seen from my other videos or elsewhere, how you can take a look at LEDs without having to get all fancy about turning them on. So take your multimeter, go into continuity mode, which is where you touch two places on a circuit to see if they're conductive, and it'll beep. But what that's doing is that's putting power through the two leads. So what you can do to either check an LED, check the polarity of the wires in case they've been trimmed or something, take your positive lead, put it on the long leg, your negative lead on the other leg. Look at that. This is a triple color LED. It goes green, red, blue. And it works, obviously. So this is this is a very handy way to not have to bring up a bunch of gear to check out an LED if you need to. Again, so that's fun. It's going to have multiple colors on the LEDs. I'll put the meter aside because we won't be needing that. And, oh, by the way, just because I keep saying it, a 4017 is a counter and divider, and it will be taking the input from the microphone and distributing appropriate electronic signals based on what it feels like the mic volume, maybe frequency too. I don't know. I haven't looked at the schematic all that well yet. And light the lights up in different colors in response to that. So I'm turning the soldering iron on. We're going to do the resistors first as always, and I'm not going to do resistor time because there's only 5 resistors, so you're not going to see that. These are, I'm trying to find, these are 470 ohm, so one of them comes off pin 12. So if this is at pin 12, then we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got my little pointy thing there so I can see which hole is blocked. Let's go in there. Now I'll take the pointy thing and go over to where it's blocked. And that's going to be R5. So R5 gets one of the 470s. Let's see where the other 470 goes. Oh, goes to ground after all the diodes. Okay, so it's at the end of D10. It's actually on, yeah, it's going to be R4 here because we're leaping across all the legs of the ICs and then going to here, which is R4, which is going hither and yon. Oh, I'm sorry. Geez. So there's 2 ways to get these resistors in the right place. You can do as I'm doing and looking for the values and seeing where they connect in the looking for the values and where they connect in the circuit. Or, alternately, you could look and see it says R5 above it and 470 below it. That says R4 above it and 470 below it. So you can actually do it without actually having to read the electronic schematic circuit flow, which just shows that sometimes I'm just an idiot. But that's okay, because I got it right, so I'm not too much of an idiot, am I? And now we've got two 20Ks, I believe. Yeah. I'm going to go ahead and do the jumpers now while I'm thinking about it. Now I have wire bending pliers, but I'm not going to use them right now because I'll use my a little bit of solder on that. I'll get rid of that. I'll use my regular needle nose because I don't think everyone in the audience has mandrel based pliers, and you shouldn't have to. You don't need them. I just have them because I got more. I have sometimes had more money than sense, and I bought some tools that I really don't need, but I wanted to have them. But using needle nose pliers to bend jumpers is something everybody can do. Now, because I put resistors on first, I shouldn't have. I should have put the jumpers on first. I have to support. I can't lay it on the mat or solder block and do anything. I have to hold it and hold the jumper with my index finger, and the jumper gets hot, or middle finger and the jumper gets hot and burns my finger, like always. There are some things I do not learn about. That's one jumper, and two little jumpers here. And I'm just eyeballing the distance on this one. I'm not going to measure it. And I got it a little bit wrong, but I'm not going to worry about that. It'll hold it in place. A little tension on it. This may have too much solder on it. It does. Unfortunately, I always have a stockpile of resistor legs hanging around, because you're gonna need them, and half the time you need them it's because you came along and you're halfway through a project and you've done all the resistors, and then you come to a step that says, oh, hope you saved some resistor legs, and of course you didn't, because you didn't know you'd need them later. So just build up a stockpile of resistor legs on a little bin on your workbench, and you'll be glad you did. Because then you won't be swearing and digging through the trash. And I didn't measure that very well at all. Nope, that's actually too thick. Let me get a thinner leg. There's a thin one. I was doing a guitar amplifier, and I had a bunch of carbon resistors, old style carbon resistors, and they have much thicker legs than these resistors, and didn't quite go through the circuit board holes here. Yep, and there I knew I was going to do that. I dragged my soldering iron across one of these pads in passing and filled in the hole. But my solder sucker fixed it right up. I do that all the time. Let's see, we'll go ahead and put the transistor on now. No, actually I think I'm going to put the IC on now. Now this, obviously, no socket, we're just dropping the IC directly onto the board and soldering it in. Get my long needle nose to make sure all the pins are parallel to each other. Make sure the dot and notch are in the right place. There it is. We'll just set that down on the board like so. Press firmly. Do one leg. Look at it to make sure it's all flush. And it is. So do the rest of the legs. I'll speed up the replay while I'm doing that. I'm going to put the microphone on now. The legs are really beat up on that. Microphones are not generally polarized. Well, I shouldn't say that. Microphones found in kits like this are not generally polarized. I'm going to put the transistor in. This is a 59014. And make sure we've got the flat side going the right way. Now, a technique that some people swear by is doing the middle leg first. And that makes it less likely that you're going to bridge when you do the two outside legs. I don't know if that's true or not, but I decided to get into that habit since if it works for some people, I have no reason not to do it. Now we'll do the electrolytic caps. Are they the same? 100 microfarad and 1 microfarad. So no, they are not the same. So here's the 100, and the 100 goes in C2. And the polarity is very clear on the board, which is nice. Long leg positive, stripe side negative. Oop. Bending the wrong way. Well, there are 3 caps, I'm sorry. This one is 10 microfarad, and the 10 microfarad... Okay, I'm not seeing it. I have C2, C3. I do not see a C1 at all. And I know it's not double-sided, but I'm going to look. Nope, it's not on the back either. Well, that's interesting. I mean, for an inexpensive kit like this, let's be clear, every capacitor counts in driving up your cost. This is C3, and that's the 1 microfarad. So I'm surprised that they gave you a part you don't need. I mean, they often do it if you do surface mount LEDs. They'll give you a couple of extra, first off because they're so cheap, and second off because the likelihood that you'll make a mistake when you're doing hand soldering of surface mount LEDs is reasonably high, and having spares is pretty good. So again, there is no C1. I'm going to put the power jumper on. Just a little 2-pin pin header cheap and easy, I could I'm not going to use that pin header. I'm going to solder the battery box directly to the board because I don't see a reason. I'm not going to use a power connector. Now I think all the diodes are the same, even though there's this one here. It's kind of off to the side. It's D11. I don't think D11 is any different. And based on what we have here, I wouldn't. Oops, sorry. Based on what we have here, I wouldn't have any idea if it was different anyway. So I'm going to do all these, rather, I'm going to speed up the playback of the camera when you see it. But what I want to show you first is for LEDs like this that you want to put firmly on the board so they're flat. Use the same technique I've used I show a number of times in videos, but this may be the first video of mine you've seen. So you just tack one leg down, put a little solder on it, lift it up, push firmly on the head of the LED, top of the LED, and you couldn't hear that probably, but it clicked down. So now it's flat as possible on the board. It's perpendicular, everything is good. So I'm going to be doing that with all 10 LEDs. And again, I'm going to put the playback in fast motion because I don't have any more commentary on that. So we'll do one leg of each, and then I'll go back and do the other leg of each. Extra parts, one capacitor, two LEDs. The pin header's not technically an extra part because they wanted me to use that, but now it's time to actually see this thing work. I will turn out this light for more dramatic effect. Okay, last battery going in. Got an LED pulsing. One, two, three. Okay, I think there's some logic here. I haven't figured it out yet. So you can read how it works. Converts the sound signal into electrical signal, and then goes to the transistor and resistor pair to amplify it. High-low voltage signal is formed at the collector of the transistor. Sufficient amplitude voltage is sent to the counting input of the 4017. Every time a pulse is received, the high level of the output of the counter is sequentially shifted by a bit, and the corresponding LED is lit, thereby generating a feeling of running water. Okay. Are you running water? Well, maybe not. L11 is connected to the 4017 counter output terminal. When 1 through 5 is lit, terminal CO. When 1 through 5 is lit, the CO end outputs high and lights up this LED when 6 to 10 is lit, low, and L10 is not light. If you think that L11 is unsightly, you can also remove it without affecting the circuit with a jumper, I assume. So that's what's happening. It's a good little kit. As you can see, it dances around as I... Ah! Ah! Louder. It's a fun little kit. Good soldering practice. It should take your beginner builder a very little amount of time to actually do this. Let me zoom in a little bit more, just for fun. One, two, three. So that's it for this evening. A cute little kit from Amazon, $6. If you have a beginner builder, get it for them. They'll have fun. They'll have this little thing they can put, I don't know, they can make a little thing so it's in their room and somebody comes in and talks and it'll light up. I can think of lots of things. I would have played with this when I was 10 or 11. So it's a pretty good kit. It wasn't from Geek Fun, but it's from Ding Dong Stores. I'm going to look them up and see what else they may have, because this is a nice little kit. Thanks for watching.